Hello, this is Itsu. Okay, this is my old Delhi nanopulser, and I was trying to see if I could use this nanopulser for pulsing this Ruslan kind of setup instead of the cache. But the problem with this nanopulser was that it does not get high enough in pulse repetition frequency. It only goes max 5 kHz, while we need at least 15 kHz to sync the Ruslan setup. So I was trying to make a new nanopulser based on the same setup, and I tried several setups, but they all had problems with oscillating, so I had a lot of amps running and a lot of high frequency noise all over the spectrum, which I could monitor with the spectrum analyzer simply. So I took a different approach and not using this kind of PCB, but a solid shield plate like again, similar to where this was built on, and I think it works rather well now, and even up till the frequency of 15 kHz. The main problem is that I can get a nice peak out of this nanopulser, but the little toroid, which is seen here, I also have one here underneath the blower. This toroid gets very hot when I increase the frequency, the pulse repetition frequency, up to 60 degrees now. And I had a earlier primary wire which I used, but you can see that it was melted. The Teflon coating, this is Teflon coating, was melted on the 3 spots, and these were all on the inner circumference of this little toroid, so the primary coil does not managed to withstand this. I'm not sure if it's the current. There's not much current in the primary, but I guess it's the fast peaks which makes this toroid and this primary very, very hot, and it's melt this Teflon. So I have to mount a big fan just on top of it to get it a little bit cooled, and that's the main problem. It still gets around 60 degrees. And I'm still looking for a kind of solution, trying to put this toroid on a heatsink is not to be done because of the influence, I guess, but I'm not sure. Okay, well, I built a power supply and a pulse input circuit. We have 24 volts input from the battery stack, and I made several voltages. We have 12 volts for the blowers, and we have 15 volt for the MOSFET driver here beneath, just soldered directly onto the source lead of the MOSFET. Presently we have 248 volts coming from this setup. I can switch between 130 and 260, or 250 and 125 or something, but I have it now in the high voltage setting. Okay, so we have 15 volts in, we have 250 volts on the drain, and the blowers are running. I have a square wave 15 kHz, 5 volts, 50% duty cycle inputs, simulating the signal which will come from the TL494, one of the to, and this circuit makes a small 200 nanosecond input signal into the MOSFET driver. Okay, let me activate the signal. I have the probe, the high voltage probe, across the 50 ohm resistor coming from the DSR diode. Okay, activating the signal, and we can see that we have a nice pulse, almost 1.5 kilovolt peak to peak, 11 nanosecond width, so it's a nice nanosecond pulse again. The problem is that when it heats up the toroid, the amplitude drops till about 1.2 kilovolts. I have my meter checking the diode now. That's not that hot, but the problem is the little toroid, which is now around 35 degrees, but it will increase slowly and it causes this to drop. Okay, still holding up. I did some tuning with the width pot to see if I could peak it, and this will cause the amp draw to go down, and okay, now you can see that the pulse is dropping 1.37 kilovolts only. This is the 24 volts input to the whole system, so slightly under 2 amps. This is the drain voltage, holding up around to 27 volts. The diode is also cooled. This is the 50 ohm resistor. Going now again to the toroid. It's starting to increase till about 50 degrees Celsius. So that is still my main problem. What I want to do is to have these pulses synced. It's a very narrow pulse, hardly registers on the scope. Nine nanosecond. So I'm kind of pleased with this performance at this frequency, but it's the limit again, and perhaps I should switch to a somewhat bigger toroid or some thicker wire. I'm not sure. It's very small wire, but there's not much current going through, I think. But okay, so next thing I will try to do is to put some coaxial cable around the inductor and to sync this nanopulse up to the TL494 and see what happens when I pulse the coaxial cable surrounding the grenade and inductor. That's the basic setup. Okay, thank you for watching. Okay, one thing I wanted to show you is that although it does not seem that I have oscillations going when I activate this is without the nanopulser active, we see the whole spectrum from 9 kHz till 750 MHz. If I now activate the pulser, we can see a lot of noise or pulses coming up all the way till about 500 or 600 kilohertz. So I'm not sure if this is noise or oscillations from the MOSFET pulser, or it's just the rapid pulses which causes this noise on the spectrum. Okay, thanks again for watching.